built form, environmentally, the envelope has four main functions. In cold weather, it's to reduce heat loss through the fabric, maximise the benefit of solar gains and internal gains, to sort of get the energy in and keep it in, and to reduce the losses associated with air infiltration. So we need a relatively airtight structure. In warm weather, slightly the opposite. We want to actually minimise solar heating, minimise internal heat gains. That will avoid overheating. So we need to think about window shading and thermal mass to attune the heat gains so they don't become excessive. We need to allow optimum levels of natural ventilation, but that would be purpose ventilation, control ventilation, and we need to think about actually making sure that we actually have a good quality daylight environment. In terms of the built form, here we've got tall, slender. We've got quite a large exposed area. We require lifts, quite high heat loss. Shallow plan, low rise, higher heat losses but increase in daylight, natural ventilation. Deep plan spaces have low heat losses. The perimeter is actually quite small in comparison to the actual volume enclosed, but truly much less daylight. Only the perimeter is daylighted, the centre needs the artificial light, and more likely to need air conditioning because the heat gains have nowhere to go. The perimeter is actually sort of dislocated. And then we've got a sort of a courtyard or atrium sort of design, effectively if you like a two-dimensional shallow plan building. So we can actually get lower heat losses because we can enclose the atrium, so we actually cut out that so we have the same advantages of deep plan, but because we've got a light coming into the centre of the building, we get better daylight penetration, and we can use the atrium space to actually enhance natural ventilation.